Hello guys, this is Reza and welcome to another exciting Niagara tutorial. In this session, we will recycle modules we have covered in previous tutorials to create a volumetric smoke entirely within Niagara without using any external VDBs. This is another technique you can add to your effects library, so without any further ado, let's get started. Here I am inside the Unreal Editor with my level already loaded. The scene is set in architectural ruins and I've placed a gas fluid emitter already in the scene. Now let's say we want to add some environmental effects like fog or in our case smoke. One approach is to create your effects elements externally and import them as VDB into Unreal. However, if you want to create the entire effect within Unreal, we have a powerful tool for that. We'll be creating this smoke effect from scratch in Unreal Engine, and I will guide you through the process step by step. First step, we need a Niagara system, an empty Niagara system. So right click in the content drawer, go to Niagara system. The UI in 5.4 is slightly different, but the core components are exactly the same. We have create empty Niagara system, and then you need to rename it to whatever you want to rename it to. I'm going to double click, and if it's not docked, just dock it right next to your level and we can get to work. Now to attach an emitter into this system, you have two options. You can press E on your keyboard and that brings in the window to add an emitter, or you can right click and go add emitter. In those cases, I'm going to go and again add empty Niagara emitter. The thing is, I really don't want to get any predefined or pre-made module in here. I want to start with the bare bones, with absolutely nothing in the scene, so it's very clear how we are going to create that. Now, if you're creating your effects as your effects library or you want to use it in cinematics, it is suggested by Epic to enable determinism, both on your emitter and on your system. And it helps you to simulate the same result with the same configuration every single time, which is, again, great for effects elements when you're working with cinematics. So I'm just going to enable determinism here, and I'm going to go into my system, and it should be somewhere around here, determinism, and I'm going to turn that on as well. Well, best is to name that something meaningful, so I'm going to call that dust_emitter. Now, as I said in my previous videos, 99% of the time, the first node or module in this case that you always need is the emitter state. And that's there to define the life cycle of your Niagara element. So I'm going to go into update and I'm going to type in emitter state. That comes up and that gives you the option to use system, meaning following the Niagara system, or go with the emitter itself. So you can set it to infinite, which is kind of similar to Niagara system. Loop that effect once or multiple times, and you can define a number of loop counts, the duration of your loop, so on and so forth. Because what we are doing is not really too specific when it comes to the timeline or life cycle of the effect, I'm just going to leave that as system, making sure that the system in here is all taken care of. So you can see if I go in here, we have almost the same effects or options, apart from there is no system self, and that establishes the duration of the system life cycle for any effects that you are going to create. If you feel like it is too short or too long, you can go and change it at any point of time. Now you have established the state of your emitter, you need to actually create the emitters. We have burst instantaneous that comes with basic forms of emitters, but for rather more complex effects, you usually go with spawn rate. That's where it allows you to define a number of particles that you would like to create. So I'm going to go into emitter update, and it actually shows up in the suggested because it's one of the most popular ones within all the modules that we have in this particular section. So you can see burst instantaneous is there as well, but we're going to go with spawn rate. If you create a spawn rate without the emitter state, it gives you a warning. You click on fix issues and Unreal is going to automatically add emitter state as well. With the spawn rate, well, we need to see how many particles we want. I'm just going to start with something like 50. I honestly don't know. We may add to it later, but for now, let's go with 50. It generates 50 particles over the life cycle that we specified. Okay, so far so good. Well, you may ask, Reza, we have created 50 particles. Where are they? Well, in the render module, we haven't specified any type of renderer. We have multiple types of renderer at our disposal, and until we specify them or pick one of them, you're not going to see anything on the screen. So I'm going to go into add a new renderer, and the most common ones, the cheapest one to run, which will suffice for the look that we're going for, is sprite renderer. It's going to create one sprite, and it's going to look at the spawn rate, finds the remaining 49 sprites, and it's going to stack them on top of each other. So what we're seeing is not one particle, there are actually 50 particles based on this spawn rate module. But that's okay, we will find a way to separate them and create a sort of a shape that we can work with. Now our job is almost finished with emitter update. Let's go to particle spawn group. And just like emitter update that we always have emitter state in there by default, I have a habit of adding initialize particle in my particle spawn. So I'm going to go in here and type in initialize. And you can see in initialization, initialize particle pops up. And the reason that I automatically add that is because every time you use sprite, mesh, or ribbon renderer, you need to add this module to initialize common particle attributes to access its common settings, such as color, such as rotation, lifetime, so on and so forth. If you don't want to change any of them, then perhaps you don't want to have initialize particle, but well, 99 out of 100, you do want to tweak the look of this boring looking sprite. And you can see I have point, sprite, mesh, ribbon, or all. We're dealing with sprite, so I'm just going to pick sprite, and these are the attributes that are available at the moment in the initialize particle. Now I know by default that anything that I'm going to create needs to have some sort of a randomization. So why don't I randomize what I have right now? And if I feel like it's a bit too low or too high, I can always go back and fix them. But not to check these guys will result in a very even looking set of particles. It's not going to be pleasing to see anyways. So I'm going to go into sprite size mode, and I'm going to random uniformly, meaning that randomize but under my terms. I'm going to set that to something like 30 to begin with and 100. This is totally scene dependent, and I might actually go back and change that, but this is just a starting point. Remember, in this section we're just blocking out attributes. We're not certain about anything. And for rotation, this is at the moment round, so rotation doesn't mean anything, but you will see that very soon we are going to apply materials to this, a puff of smoke, and that is going to rotate. So we don't have every single particle to have the exact same shape. We want a little bit of randomization in there. So I'm going to go in there and just set that on set to random for sprite rotation mode. Now let's deal with the situation that we have multiple particles stacking on top of each other. The reason is because we haven't specified any type of location for the particles. Niagara doesn't know how to distribute these particles. Should that be in a cone shape? Should that be in a cube? Should that be in a form of a sphere? Or what have you. So we need to actually tell Niagara how to break this apart and show us all 50 particles that we specified. And we do that in particle spawn, because now we are in the particle stage, particle creation stage, not the emitter stage. So anything that we do, at least in this level, goes into particle spawn. Now, there is a really useful module called shape location. If I type in shape location, it comes up in the suggestion. And if I click that, you can see now Niagara is trying its best to separate them, but of course we need to make further tweaks. Let's look at the attributes. Shape primitive set to sphere. Well, funny enough, if I click here and type in sphere location by itself can be a separate module, although we are not going to use sphere. We rather use box or plane, and it creates some sort of a box looking shape. We need to increase this fall off, this box, to separate them further. So I'm going to put a big number here, something like 500. If I go in here so you guys can see what exactly is happening, to 500. Now it's more like a cube or box. And I'm going to squash this box in Z-axis simply because I don't want this smoke to cover too much of this area. I want this to be more close to the surface. So I'm going to put 1 here, but I will allow myself to go there and change that if need be. One important attribute that I'm not going to use, but I really want you to know about it, is also this surface only. If that is enabled, these particles will attach themselves to the surface of the box, not inside the box. So if I go press that 100, if I go back into initialize particle and just reset these values so you guys get to see things better, you can see that they are connecting themselves to the surface of this box. Whereas if I turn it off, they're going to go inside the box and kind of fill that volume. We do not want to have surface only on. I'm going to go into initialize particle and revert these values. We'll see how we go with these values. If it's too high or low, we'll change it later. Now, one issue I have with this progress so far is these particles are not dying, as if there is no life cycle to them. So there is a life cycle option. If I go into point, there is a lifetime that you can actually specify. I'm going to set that to 5. But even if you change that value, you can see they're just sitting there looking at us, not dying, which is a very common thing. And if that happens, you need to go into particle update, because particle update deals with after particle spawn, after creating the particles, what's going to happen to the particle goes into particle update. You need to create a very particular module called particle state. And there's not much in particle state. It only says, please kill these particles after the specified values. So if I go in there and play, you can see some of them live, some of them die. Now we're talking. So don't forget to put particle state in there if you really want Niagara to follow what you have specified in your lifetime attribute here. Now I have the initial modules blocked out and ready to go, but well, one big issue is I really don't want my dust to look like sphere. I want them to look like puff of smoke. Now we are going to mix what we have learned in the creating fire tutorial and a brand new method to be able to connect materials into our Niagara system so we can control certain attributes via the material editor and link that into this emitter right here to improve on the look of this sprite renderer, which at the moment is default sprite material. We're going to create a material in the material editor, replace it with this one, and take it from there. Let's go to the next chapter. Now let's create a brand new master material to animate over time. Again, we did something similar in creating Fire Niagara tutorial, but we are going to add layers to that. I'm going to right click and call this mm_smoke. And let's double click on it to go into material editor. Right off the bat, think about the type of material we are going to use. It's smoke, it's not opaque, it's semi-transparent. So we need to change the blend mode from opaque to translucent. And that gives us the opacity that we definitely need, and it gives us the base color. And this base color, we are going to do something in a way that it's going to control the color of this Niagara system. First things first, I'm going to create a particle sub UV, and that is going to give us some sort of a texture, and Niagara will use that texture to replace it with these boring looking spheres. And if I just type in particle sub UV, the look of this is very, very similar to a normal texture sample. So if I bring in a texture sample, they almost look identical with one big difference. In texture sample, we start with material expression texture sample and we specify our texture here. In particle sub UV, we have material expression particle sub UV first, and the rest is identical. So don't confuse the two. We need particle sub UV to assign textures to our particle. There is actually an out-of-the-shelf texture in Unreal Engine that we can practice with, and if we're unhappy with it, we can always create our own custom one. So smoke, there you go, smoke sub UV. There is one smoke sub UV 8x8. That's actually a good one. If I go in there, bring that up and look at it, right now alpha is on. I'm going to turn off the alpha. You can see we've got the sequence 8x8 ready to go. And the big difference between this particle sub UV and animation sub UV that we used previously is this one is not looped. So if you look at this first one and the last one, they're actually different. And I will show how to actually make that look loopable. But just keep that in mind. So let's go back into here. I have this. I need another node to work with, and the other one will define the base color. This one goes to opacity. So let's create particle color, and this particle color is an input data, and that is going to define what color you would like to assign to this look, to this particle smoke that I have here. Obviously RGB, go to base color, and I would like to get an alpha here and get an alpha here and multiply them so they go into opacity. So I'm going to hold down M on the keyboard and single left click, A to A, B to alpha of our particle sub UV, and the result goes into opacity. And what I'm getting is the puff of smoke, but the color of it will get controlled by this particle color. And you may say, why there is no color chip here? Can we change the color here? No, we actually changed the color within our Niagara, but Niagara is now able to read this structure right here. And because we have added nodes with the word particle in them, Niagara has no difficulty reading them from this material editor. So I'm going to make sure that I'm saving this. Now let's assign this to our sprite renderer. So I'm going to go in here. Actually, one easy way of doing that is to select your material and then go to Niagara, select your sprite, and just click on this arrow. That's going to use the selected asset in the content browser, which is the Niagara, to the sprite. So if I click, it will just drop this look onto every single particle. So ideally we have, how many we specified? 50. We have 50 of them on the screen. Well, I don't need to say this, that this is not what we want, but at least the connection between the material editor and Niagara has been established, and Niagara, through these particle nodes, can actually feed information into my sprite renderer. I hope it makes sense. Only then we are going to use our good old sub-UV animation. And we do that in, again, particle update, because, well, it happened after the creation and we're trying to change the behavior of our existing particles. It is really important to define and to understand when to use what node or what module and where to use them. Particle update would be a great one for our example. So I'm going to type in sub UV animation. Sub UV animation comes up. We are going to add that. It sort of errors out, gives us a warning that, okay, you want me to blend a flipbook image, but where is it? Have you applied that to your sprite renderer? If that's the case, can you just introduce that to me? And that is via sprite renderer, which by default set to none. So I'm going to go and say, well, we have one sprite renderer, let's use that one. It's still going to show us this result. Again, if you have followed my creating a fire tutorial, you exactly know how to fix this. You need to go into sprite renderer, into sub UV, and say to Niagara that yes, I am actually using sub UV blending. And if you remember in here, the one that we used was 8 by 8. So I'm going to go in here and say it's not 1 by 1, it's actually 8 by 8. And only then we get the right look. So if I click and play, you can see the puff of smoke is actually happening. Now we are going to drop that into our level very soon, but before I do that, let's not forget about initialize particle. Now we have the particle color in place. Let's go ahead and tweak a few things in the coloration. I'm just going to block out some sort of a grayish looking color, and I'm going to reduce the alpha ever so slightly. So I'm going to reduce it to half actually, so it's not too opaque, too strong for our smoke effect. Now with that out of the way, we've pretty much done with the material part. Well, there is still one issue that we need to investigate, but we're not quite there yet. Almost finished with our material editor. Let's go to the next chapter, drag and drop this into a simple level, not the fancy one that we have, into just a simple level, and identify what problems we're running into, and gradually but surely add layers into what we have. All right, here I am inside the main level. So I don't want to do these tests and look dev tests too early in my original level. I just want to do it in the main level first and identify issues, fix them. Only then, when we're getting closer to the result that we want, we are going to drag that into our scene and we are going to tweak that further. So I am going to just drag and drop it in here to see what we're dealing with first. And okay, one issue I can immediately put my finger on, which becomes really obvious if I go into alpha and set that to 1, is that clipping line. There you go. See that? That clipping line that collides with the ground is very ugly. That's one issue. The other one is this popping. So these particles come and go due to the life cycle. They die and they appear, and that looks really ugly. It doesn't look like they're blending together. So obviously these two issues I need to investigate before I do anything else, and let's get to those. The first one is the clipping, and it's a very easy fix every time you run into this, where you have a type of effects and it's not colliding well with the geometry. It can happen with fire as well, especially if you have, let's say, a candle light and you've got a wick for the candle and you want to smooth out the transition. That node can be extremely useful, and it's called depth fade. So you can type in depth fade. Let's bring that in. It's got an opacity and fade distance, which you can sort of increase and decrease the fall off, how much you want to have that fade from the bottom of your effects, and it sort of fades it upwards based on this value. I noticed actually the value of 100, which is the default, works pretty well. But if you feel like it's not getting the result that you want, hold down one single left click, and this is going to sort of control this value. You can parameterize it, bring it in to your material instance if you want, and tweak that on the fly. We don't need that at the moment. So we're going to put that here as a bridge, as a middle person, and that should fix the issue. I'm going to go save, and you can see instantly that harsh line has been fixed. So it's still there, but because there is a fall off to blur the effect, you're actually not going to see it, which works out pretty well for us. The other issue is the popping. So what we have at the moment is we do not have any module to smooth out the scale of our alpha. Right now it's fairly Boolean, yes and no, black or white, 0 or 1. And if that situation happens to you, you can have a scale color module to be added into your particle update. Again, it's a behavior we are trying to change. It's not the creation phase of our particle, so it goes into particle update. I'm going to call that scale color. And while we're not really changing the color, we've already specified the color, it allows us to have access to scale alpha. So that's the one that we're going to target. We're not going to touch these colors because, well, we already have a node for it, and we tweak that through the initial particle, so that part is not going to be changed. With the scale color, we are going to only deal with scale alpha. Now, right now, it's a float value. So it means that anything that you put in, there is no over time factor. It's either going to be that value or going to be 0. And any value you put in is not going to solve the problem unless you go in here and add some of these suggested workarounds. One of them, which is a godsend, and I always use that, is float curve. So this float value we have will be turned into a curve which can be changed over time. Very useful. So if I click on that, all of a sudden I'm getting an F curve, which I can open in our curve editor, and it specifies the interpolation. The one that I really like is if I click on this arrow and go into ramp, pretty much the last one, ramp up down. If I click on it, you can see it changes the interpolation. It says no alpha, so completely transparent, and then gradually make it opaque, but then gradually make it transparent again. That fade in and fade out is going to fix the popping. If I run this in the timeline, you can see how smooth they're looking. They're fading in and out of each other. I'm going to go into initialize particle. I'm going to go into color, and I'm going to bring that back to 0.5. Now let's see how it looks. You can see it looks a lot better. You don't at least feel the popping at the moment. So we managed to fix these two issues in this chapter. Let's go to the next chapter and address some other elements that I feel like we can add to visually make this look more pleasing. Now we're almost towards the end. If I were to put my finger on one issue that I see in here, is the smoke is very static. It barely moves, and the animation that you see is due to random rotation of each particle, and of course the fade in and fade out that we created using the scale color. And by the way, this scale curve is the general multiplier, which one for that is probably a bit high. I'm going to reduce it to 0.8. You can make this very opaque using a high value. You can see you can pretty much create clouds with this if you want to, but for smoke, maybe 1 is a bit of an overkill. Again, I will keep an eye on this if I feel like it's too high. Let's add some force fields. And every time I talk about force fields, just like emitter state that I add automatically, just like initial particles that I add automatically, there is a module that I add automatically in particle update when I'm dealing with force, and that is solve forces and velocity. And I actually wish to add both velocity and some forces. Solve force and velocity. There's nothing in there for you to change, but it is a requirement every time you add any type of velocity or any type of force field. Again, just like emitter state, if you forget to do that, Unreal Engine is going to prompt you to add this. You click on fix issues and that will get added automatically. But I usually add it myself before Unreal Engine gets out of control. All right, we have this, so we can add any type of force fields. Let's start with velocity. And the velocity on this one should happen at creation. So when the particles are born or get generated, I want the force field to take place. And for that particular reason, I'm not going to add that into particle update. I'm going to target particle spawn. So velocity, add velocity. I'm going to add that in. By default, it's going to push everything into z-axis. Well, in Unreal Engine, z-axis, positive z is up. Unlike some other applications like Maya, which y is pointing up. We don't want that, so I'm going to zero that out. And maybe I'm going to add something like 15 in here. But you know what? I'm going to randomize that as well, because a fixed value never works, especially for effects. You need to have a little bit of randomization. So what I usually do, especially with force fields, I'm going to add random range. I'm going to click on this drop down value and type in random range vector. And what that's going to do, it's going to turn that fixed value into minimum and maximum. And that gives you a far more natural looking force field. I'm going to set the minimum to 0 and maximum to, say, the original 15 that we have. And that gives us a little bit of frequency, which is always nice to see. And that happens over time. Velocity is good. I'm actually quite happy with the look. If you're aiming clouds, then obviously that will be slightly slower, and you can move that to something like 3 or 4. Again, we're blocking out values. If it's too high or too low, even for your own project, you know what to do, where to find this value. Now we have this, and that looks good, but I need chaos. Velocity is going to push, but it doesn't add noise. And that's exactly what I need to add a little bit of chaos and randomness, especially with smoke. So many external elements are going to change the look of the smoke. So having a turbulence is a must-have. Turbulence is one of those nodes that is going to change the behavior of the particle. And for that particular reason, that's enough for me to add that into my particle update. So I'm going to click and type in for curl noise, which is equal to turbulence in other DCCs. I'm going to drop that in. And you can see immediately this is going to create chaos. Every time I use curl noise, I need to tame it, either to tone this down, the noise strength, but I really like the chaos, but I need to tone this down or tame the effect, so to speak. And there is a perfect module for that. It's called drag. I'm going to drag in drag. See what I did? And then in drag, you can see now we're getting turbulence. It's just not as crazy. So things are not flying off. I feel like a value of 1 is a bit too much. So I'm going to reduce it to something like 0.8. And that should give me a good result, maybe 0.7. So it doesn't kill all the movements. Yeah, that looks good. So a little bit of flying off, but it's not extreme. It's very smoke-like. Very cool. I'm going to save. And probably that's not a bad time for me to actually test this effect in the engine and see how it looks. Oh, by the way, one really important thing that I tend to forget to mention to students is that local space, which is by default off. So if I go to, let's say, initialize particle, go in there and set the alpha back to 1, so we get a more of an opaque scenario, and then go to scale color, bring this one to something like 5. So everything is far more noticeable. If I move this up, you can see these guys are kind of catching up and then they go all over the place. And this happens because of this local space. Now that might be the look that you are looking for. And this is something that is compatible with all type of effects. Local space off. You can enable local space. Look what happens when I have local space. If I move it up, it's more like a unit. It's like it's attached. The whole effects is attached to my gizmo, and I can move it up and down. I can dress the set, rotate it, or what have you, which can be very useful, especially if you're looking for creating archives of effects and just drag and drop them. Having said that, a bit of a disclaimer, sometimes local space doesn't work with certain effects. It's really beyond the scope of this tutorial to explain on what type of effects and how it happens, but just keep an eye on it. Definitely test it. If it's not working, just turn it off. For now, I'm going to leave that on. All right, let's go to the final chapter. We have something really beautiful. I'm going to revert some of these attributes and values to the original values that we set. And we're going to go to the final chapter, and we are going to bring our effects into the scene and see how it looks. Now let's drag and drop our Niagara system into the scene. Now this scene has got a very different scale. It's a ginormous scene. So for sure that Niagara system is going to be super small. Well, to avoid that, one thing you can do is to make sure that you build it right in the scene. Another way is to block it out, bring it in, and then make changes if you want to. But if you were to scale it up, let's say I'm going to scale it up here, you can do it with the box, the volume box that you have available. The particle separation happens where particles are not big enough to blend together. I'm going to change some of these to make sure that what I'm getting is right, but yeah, that's the problem. So with this issue, we need to see and investigate what we need to change in order to fix the issue. Let's go ahead and look at what we have. Well, particle spawn 50 may not be enough because we have a big scene. I'm going to bring that up to 60. With initialized particle, the lifetime I think works for us really well. The color, I didn't mind that, so that's not an issue. With shape, that's where you can increase the box, but again, particle separations do happen in scenarios like this, so that's not going to work for us. But if I go into sprite size, that's where I need to change stuff. I'm going to, instead of 30 and 100, I'm going to go 300 and 1000. Now that's going to create a very big volume for me. Let's see how it looks. Let's go back. Much better. So you can see the smoke flying off. It's tamed. It's not going all the way to the sky. At the same time, I can totally see that. And the beauty of Niagara is light can interact with it as well, and goes in and scatters, and that's why you see some sort of a volumetric blue here, because I've got a blue light here and a volumetric yellowish orangish color, low temperature color, and beautiful. So of course this is just an hour of work and I need more time to tweak it and look at it and make it exactly what I want, but that should give you enough ammunition to now take this technique and use that in your own projects. This is great. I hope you found this video useful, guys. Definitely follow me on Reddit, Instagram, and X. Have a great rest of your day. Until the next video, see you guys later.